Have you ever seen laboratory mice? They have to spend their life running around in mazes. It's a bit sad, actually. Now, if we look at this pair of mice, we have a square track. So they are going to run in not that much of a maze, but just around the square. And they are going to run for 11 minutes in opposite directions. They start from the middle of one side. So the picture looks something like this. This is the track that they're running on, and they start from the middle of one of the sides. So maybe from here. One of them takes 80 seconds to run all the way around. So when one of them goes this way, this mouse takes 80 seconds to run all the way around. I'm going to write seconds here because sometimes we're used to thinking of a number as measuring the speed. This does measure the speed, but it measures the time. And so it's not going at 80 somethings per second, it's going to take 80 seconds. The other mouse is going in the other way, and it's a bit slower. It takes 90 seconds to go all the way around. Now, the question asks, for what fraction of the last minute are both mice on the original side from which they started? The meaning of this is they will go running around and around at different speeds, and they are running for 11 minutes. The last minute is from the 10th minute, from 10 minutes after start until 11 minutes after start. And the question is, for what part of that time are they both on this side? Whenever I see a question like this, I'm very worried. Because the way to do a question like this is to calculate a lot of these positions of where they are very carefully without making a mistake. I want to give you a tip. Whenever you're doing a question of this type, for which there's a lot of calculation, it's very important that every step that you calculate is correct. This is actually where it's sometimes helpful to think about number sense. Or if you have worked with a lot of numbers before, you might notice if you have a number that doesn't make sense. I will get onto that as we're doing this calculation. But the other piece is, you want to be very organized and careful at how you write down everything so that you don't make a mistake by accident. With so many calculations, one mistake can cost you the entire answer. Now, this is asking about the final minute, which is 10 minutes after the beginning. Okay, if it's 10 minutes after the beginning, what I'm curious about right now is I would really like to know exactly where both mice are at exactly 10 minutes after the beginning. So, in other words, this time, 10 minutes after the beginning, is 10 times 60 seconds. So I really want to know what is the picture at that time. Now, if that's the number of seconds, let's remember that one of the mice who is going this way, this mouse was running at 80 seconds for each round. So as a fraction of how far around the mouse is, I would take 10 times 60 divided by 80, and I see fractions already, but this is where this number sense is useful. I'm going to cancel the 60 and 80 right away as 3 and 4, and then I will cancel the 10 and the 4, and I will get 5, 2 here, and the whole thing becomes 15 divided by 2. So what this means is that this is 7.5 rounds. I'm going to use a mixed number here because once you go all the way around to the starting point, it doesn't really matter. Remember, we're only asking what fraction of the time the mouse is on this top edge. So the important part here is this 1/2. And what this means is that there's one mouse who is right here at the bottom, and this is the 80 mouse. 80 seconds for one lap mouse. Okay, so far so good. What about the other side, the other mouse? The other mouse is going this way. The same calculation means that I should take 10 times 60 seconds over 90 seconds for one round. Here, I can cancel, and I see 2/3 right here. And so this is coming out to, and so this is coming out to 20 divided by 3, which, especially if you've seen a lot of these numbers before, you recognize that this is 6 2/3. you notice every time I'm being a little bit careful and thinking, am I making a mistake on this equals? Am I making a mistake on this equals? Because I don't want to have mistakes cause me to go and get a completely wrong answer. But this is saying 2/3 of the way around. That's not very nice. This is a square. It's very hard to draw a point 2/3 of the way around a square. So what that means is I'm actually going to draw a new picture where I'm drawing a circle instead of a square, because all that matters are the fractions. Okay, so now I'm going to say at 10 times 60 seconds, here's what the picture looks like. I have this. This was the start. I have one mouse who is here and going this way at 80. I have another mouse who is, it says 6 2/3, but remember it's going in the other direction. So it's going to be about here, and it's going at 90 seconds for one round. Let's remember that this is actually 1/3 of a circle. Now let's think about what the question was asking. The question was asking when you're within this top segment, which is 1/4 of the circle. So now I'm going to draw the center of the circle and mark off 1/4 of the circle. I want to know for how long in that last 60 seconds both mice are in here. So let's calculate that for each mouse. Since I was just doing this one, and in the back of my head, I'm remembering that this is 1/3 of a circle away. I'm just going to write this 1/3 here. This is 1/3 of a circle away from this point of view. I can then find out how long it takes for this mouse to get to that point. So let's start to work all of these details out. This point is at 1/3. This point here is actually at 1/8. So from here to here, the gap is 1/3 minus 1/8, which is over 24, 8 minus 3, which is 5 divided by 24. Here I just did some fraction arithmetic. I'm always afraid of mistakes with fraction arithmetic. So I'm going to immediately do that fraction arithmetic another way in my head to check. The other way is that I will say, I remember that 1/3 compared to 1/2 is 1/6 away. So what would I get if I subtracted from 1/2 1/6 plus 1/8? If you add 1/6 plus 1/8 together, I can put that divided by 24. It would be 4 plus 3, 7 over 24. And what happens if I take 7 over 24 subtracted from half? Yes, 5 over 24. I'm just showing you the kind of things I'm doing to make sure I don't make a mistake. Okay, so that's 5 over 24 of a circle. Remember, it takes 90 seconds for this mouse to go all the way around. And so how much time does the mouse spend to get to that point is the product 90 times 5 over 24. Well, here, let's start canceling. So with the 24 and the 90, one of the first things I see that I can cancel is the 2, 45, and the 12. Then I see I can cancel a 3, 15, and a 4. And so what I get is 15 times 5, which I recognize to be 75 over 4. Wow, that is a terrible, terrible number. But that's okay. We're going to keep going forward with brute force anyway. I want this thing in mixed number because remember that I only have 60 seconds left, and I'm curious how much of that 60 seconds this is. If I divide, 4 times 1 goes into 7, 35 is left over, so I have an 8 for a 32, 3/4. And I mentally check, 18 and 4, those are friends. 18 times 4 is 72. That's a common thing that you multiply. So that's good. So in 18 and 3/4 seconds, this mouse gets to this point. But how long does it take for this mouse to exit all the way around? So if this mouse then continues all the way around to this part, this is another 1/4 of a circle. So this one is easier because I just need to have 1/4 times 90. 1/4 of a circle times 90 for all the way around. And this is where, again, it's useful to be familiar with these numbers. Actually, the way that sometimes I do this is to do a quarter, you take it in half first, which is 45. And a half of 45, these are geometry numbers. Half of 45 is 22 and a half. Okay, so now I know that from 18 3/4 to 18 3/4 plus 22.5, this mouse is in that region. Do I need to worry more about this mouse? Will it get all the way around again? Well, no, because it takes 90 seconds to go all the way around, and it will not possibly get another 3/4 of a round before I run out of time. So now I finally know something very good about this 90-second mouse. Let me add these two numbers together, 18 3/4 plus 22.5. If I do that, let's just do that here. 18 3/4 plus 22.5. I'll actually write them as decimals, 18.75 plus 22.5. I'm doing them as decimals because I have mixed numbers anyway. So 5 is here, 7, 5 is 12, 1, now I have 11, 41.25. Finally. So what I have found out is that for this 90-second mouse, this 90-second mouse is going to be in that region that I care about from this time, 41.25, from this time, 18.75 to 41.25. Okay, well, let's keep going. The other mouse. So for the other mouse, I have 80, and this is an 80-second mouse. Over here, I'm already at half. This is at 1/8. So I'm curious, how long does it take to go 3/8? I'll do the same kind of calculations as the other side, so let's just do it faster. When I go to this part, then I'm doing 3/8 times 80. Oh, wow, this is easy. This is just 30. So at 30 seconds, this mouse gets here. How long does it take for the mouse to exit the area? That's 1/4. So to finish this, the mouse will finish in another 1/4 times 80. 1/4 times 80 is equal to, divide by 2, 20. So this mouse is in this region from 30 seconds to 50 seconds. This mouse is there from 18 3/4 to 41.25. So when are they both inside? It looks like the limiting factors are this time 41.25 and this time 30. Because even though at 18 3/4 this one got in, this one is not in yet. I'm almost done. Now I finally take these two together. So the question asked, out of 60, how much of the time are they both inside the region? So the difference here is 11.25. Okay? So the answer is 11.25, which I'm going to write as 11 1/4, divided by 60. I wanted a fraction. So I used a mixed number because I can make the top into a fraction. The top becomes 45 divided by 4, all divided by 60. Oh my goodness. 45 and 60, I never expected that they would cancel so nicely. This is going to give me, if I divide by 15, 45 gives me 3, 60 gives me 4, and the answer to the entire question is 3 divided by 16. Okay, this is an example of a question where really all we did is use distance equals rate times time, except that we had to do it about 4 times. And this is very dangerous because it's very easy to make a mistake. The best way to make sure you don't make a mistake is perhaps to draw some sort of a diagram and label the diagram in a way where you can see what each of those distances is, what each of those times is. Here I was doing it on a board. When I was actually doing this problem, I used a piece of paper and I used even more space, very clearly writing down what each of these things was. In the end, when you're doing a question like this, I'll say that it's not as much a problem of understanding what to do, because here it was clear what to do. It's just a question of doing it carefully. For such problems, rather than going super fast, it's best to take the same philosophy as a marathon runner, those people who run 26 miles. Marathon runner means that you want to keep your pace solid all the way through. And this is an example of how you go about doing that. In some sense, we deserve to do this because the mice are running a marathon too.